So moving on to example 5, it says find the exact measures of UV and TV using the 30, 60, 90 triangle theorem. So as you can see, this is a 30, 60, 90 right triangle. Once again, the right angle is 90. If they give you a 30 or a 60, then you'd be able to find the others. So sometimes they'll say 30, 60, 90. Sometimes they'll just say 30, 90 and have you figure out it's a 60, or 60, 90, figure out it's a 30 because there's 180 in a triangle. Just like the 45, 45, 90 triangle, the 30, 60, 90 has a similar triangle that's always similar, and that is this one right here. I'm going to draw it the same orientation, so I'm going to put the 30 and the 60 and the 90 in the same positions. So 30's here, 60's down here, and 90's up here. And the relationship between these three sides is the smallest side is 1, the biggest side is 2, and the side in the middle is the square root of 3. I know the smallest side is, let's call this ABC. I know that BC is the smallest side because it's opposite the smallest angle. I know that AC is the longest side because it's opposite the biggest angle, 90. And I know that AB is in the middle of those two because it's opposite the middle-sized angle. The square root of 3 equals about 1.7, so 1, 1.72, smallest, medium, biggest. All right, so that's the relationship of the three sides. Always those three numbers, 1, 2, and the square root of 3. All right. Once you establish those three sides, and again, I've drawn the orientation the same way, this side, BC, corresponds to UV, and AC is going to correspond to TV, and AB is going to correspond to TU. So if you draw the orientation the same way, all the corresponding pieces are right lined up nicely. I'm going to call this side over here side T, and this side over here side U. Again, big T opposite little t, big U opposite little u. You don't have to use those letters, but that's typically what books are going to do. So I like to kind of do what the books are going to do, so I'm familiarizing myself with that idea. And once again, these are the ones I'm looking for. I know TU, so when I write my proportion, I'm going to put fraction with either U or T on top. I'm going to put fraction with a 9 square root of 3 on top. I'm going to put a fraction with T on the top. I want the one I know in the middle and the ones I don't know on either side. Again, it doesn't matter which one's which. Once you've established how the top is going to go, though, the bottom is dependent upon position. So U matches up to 2, so U and 2 are in the same one. 9 square root of 3 matches the square root of 3, they're in the same one. And 1 matches T, so they're in the same one. Before you start cross multiplying, which is, you can do it immediately if you want to, but before you do that, you might consider this. Sometimes there are common factors, reductions possible within those fractions. So that middle fraction, the square root of 3's are the same on top and bottom, but they can cancel. And I usually don't cancel much stuff when I'm doing proportions, but if I can get rid of a radical square root object, it just makes life easier, makes it easier to look at, right? Square roots of 3 go away. So this is 9 times the square root of 3 over the square root of 3. Those cancel, so basically it's 9 over 1 now. So if I cross multiply this one, I'm going to get 1 times U equals 2 times 9. So U is 18. I could cross multiply this one, but notice it's T over 1 equals 9 over 1. So T is equal to 9. If you cross multiply, you get the same result. T times 1 T equals 9 times 1, 9. All right, so those are my answers. Again, that's U and T. They asked me for UV and TV, so for good mathematical purposes, I'm going to say UV equals something, TV equals something. UV is being represented by the letter T, and T is equal to 9. TV is being represented by the letter U, so U is equal to 18. So that'd be my answers for that one. And it does say find the exact measures. 9 and 18 obviously are just integer answers, but a lot of times you get radical answers to these problems. So make sure square roots end up in your answer if they do still exist. Moving on to 5b, same idea. It's still a 30, 60, 90 right triangle. Still 9 times the square root of 3 is one of the sides, but this time with 9 square root of 3 is the hypotenuse, not the side opposite 60. My corresponding similar triangle here, 30 up in the corner, 60 down in the bottom corner, and 90 up in the top right. So getting everything oriented the same. The numbers are 1 on the smallest, 2 on the biggest, square root of 3 on the middle. 1, 2, square root of 3 every time. I'm going to call this ABC again. All right. So ABC is similar to TUV. Side AB matches up to side TU, side BC matches up to side UV, and side AC matches up to side TV. I'm naming these this time. Angle V is going to be opposite of side V, and angle T is going to be opposite side T. Again, you can pick AB every time, XY every time, doesn't matter what you call them, but I'm just going to keep doing it that way. So V over something equals 9 times the square root of 3 over something equals T over something. Every time I make the top the same way, something I don't know, something I do know, something I don't know. And then I put the matching pieces on the bottom for each letter. So V matches the square root of 3. 9 square root of 3 matches 2. T matches 1. So now I got my proportions built. My left proportion has V only in it. If I cross multiply, I'm going to get 2 times V equals this product. Now, when you multiply square roots together, okay, product of square roots theorem states, if you multiply the square root of a positive number times the square root of a positive number, you get the square root of the product of those two positive numbers. All right? So the square root of 3 times the square root of 3 makes the square root of 3 times 3, which is the square root of 9. Square root of 9 happens to equal 3. Okay, this is not a theorem so much, but it's just an observation that's going to happen every time. When you multiply a square root times its identical twin like that, you get the number without the square root on it. You don't have to go through this middleman every time. Just if you feel comfortable with that. Square root of anything times itself makes that number without the square root symbol on it. All right? So when I'm multiplying this, 9 times square root of 3 times square root of 3 is basically just 9 times 3, which is 27. And if you become comfortable with that idea, then it can just be something you'd be done mentally. All right? Square roots of 3 multiplied make 3. 3 times 9 is 27. Write down 27 and you see that product. Okay, it's something you want to become familiar with because this type of structure happens very often in this class as we continue on, and definitely in Algebra 2 when we see it next year. It's going to happen a lot in Algebra 2 where you're multiplying square roots times themselves. You want to become familiar with that idea. If 2v is equal to 27, then v of course equals 27 over 2. I'm fine leaving it an improper fraction. If you want to make it 13.5 or 13 and a half, those are still exact values. There's no rounding necessary. So and when it says exact, we're looking for a non-rounded idea. So I personally leave it as a fraction, 27 over 2. The other thing I need to find is t, which is uv. This proportion here will get that done for me. If I cross multiply, I get 2 times t equals 9 square root of 3 times 1. So 2t equals 9 times the square root of 3. Divide both sides by 2. And once again, I'm going to leave that just as it is, 9 square root of 3 over 2. Perfectly fine answer on these problems. So, reverting back to the original names, V is actually side UT or TU. Oh, I got to do a better job. UV and TU. I have to re-type my sheets here. So UT is V, so UT is equal to 27 halves. And UV equals 9 times the square root of 3 over 2.